So we are studying a detailed, you can say, revision for the course of mathematics of class 11. That is, today we'll study about, it will be a one shot, okay? We'll study about sets and functions. Again, we'll study about relations and sets, relations functions, geometric functions we'll study. We'll study about algebra, where the principle of mathematical induction is there, complex numbers and quadratic equation is there, linear inequalities, permutation and combination, binomial theorem, sequences and series, coordinate geometry, straight lines, conic sections, and introduction to three-dimensional geometry, limits and derivatives, mathematical reasoning, statistics, probability. We'll study all the things step by step. So firstly, we'll try to review all the final, you can say, pages here. We'll review all of them together first. Then we will go to, let me just go to the summary page, and yeah, summary of key facts of sets. A well-defined collection of objects is called a set. The objects in a set are called its elements for members or points. Usually, we denote sets by capital letters A, B, C, X, Y, Z. Any letter can be used. A set is usually described in tabular form or set builder form. In tabulation method, we make a list of all objects of the sets and put them within braces. So in tabulation method, whenever any word tabulation is asked, we make a list of all objects of the set and put them within braces. In set builder, we write X is such that X satisfies property P, which means the set of all those X, so that each X satisfies property P. A set having no element at all is called a null set or a void set, and it is denoted by phi. Okay, a set having a single element is called a singleton set. For example, bracket 3, a set having finite number of elements is called finite set, otherwise it is called as infinite set. The number of elements in a finite set A is denoted by NA. Two sets A and B having exactly the same elements are known as equal sets, and we write A is equal to B. A set A is called a subset of a set if every element of A is in B and we write A belongs to B. A is a subset of B. So a set A is called subset of a set if every element of A is in B and we write A is subset of B, and if A is subset of B and A is not equal to B, then A is called a proper subset of set B, and we write A is a proper subset of B. Total number of subsets of a set A containing n elements is 2 to the power of n. Total number of subsets of a set containing n elements is 2 to the power of n. The collection of all subsets of a set is called the power set of a set, to be denoted by PA. A and B be real numbers such that A is less than B, then close interval AB can be written as X such that X belongs to R and A, and X is greater than equal to A and less than equal to B, open interval here, equal to part will not be there. That is X is such that X belongs to R, real numbers, and X is greater than A and less than B, right half open interval. Whenever right half open, when the RHS part will be open, the LHS part will be closed. So X is such that X belongs to real numbers, X is greater than equal to A and less than B, and similarly left half open interval. So in that case, left will be open and right is closed. And we can mention as X is such that X belongs to R, X is greater than A and less than equal to B. The union of two sets A and B denoted by A union B is a set of all those elements which are either in A or in B or in both A and B. Union of two sets A and B denoted by A union B is a set of all elements which are either in A or in B or in both A and B. Therefore, A union B, X belongs to A or X belongs to B, because in union total is counted. Intersection of two sets denoted by is a set of all those elements uh, which are common to both A and B. A intersection B is equal to X is such that X belongs to A and X belongs to B. The difference between the two sets A and B denoted by A minus B is defined as A minus B is equal to X such that X belongs to A and does not belong to B. And whenever we write B minus A, so in that case X is such that X belongs to B and X is not belonging to A. Symmetric difference between the two sets A and B denoted by A symmetric B is defined as. Now the symmetric difference between the two sets A and B denoted by A delta B or symmetric B, this triangle, you can say symbol is there, is defined by A delta B or A symmetric B is equal to A minus B union B minus A. Whenever we say A minus B, it is all A not B, and B minus A is all B not A. Okay, union of both of them, or we can say union of the A part only and B part only. Let A be a subset of the universal set U, then the complement of A denoted by A dash or A to the power of C or U minus A is defined by A dash or A prime is equal to X such that X belongs to U, X does not belong to A. Okay, so let us understand further. Let A be a subset of the universal set U, then the complement of A denoted by A dash or A to the power of C or U minus A is defined by A dash X is such that X belongs to U and X does not belong to A. So for the various laws of operations, A union A is A intersection again A in the identity law, union of A with phi is A only. With union of this intersection of this will be A only. A union B is equal to B union A, and similarly, the intersection also applies, and competitive law is already applicable. A union B complement is A complement union B complement. So now here this Venn diagram is important also. Whenever two sets are the A and B, that A union B number of elements is equal to n A plus n B plus minus n A intersection B. That is very easy to do. Otherwise, we'll have wrong results. So n of A minus B will be equal to n of A minus B plus n of A intersection B. Now, if I check the intersection part, in that case, can be written as, okay, we can see all this formula, that is union of these two will be summation of the separator minus intersection. Minus will be A minus B will be plus A intersection will be an A for any three sets. Whenever we have a union of all three, summation of the separate terms minus n of, it is being so n number of elements of A intersection B reals into number of elements of uh, n B A intersection B B intersection C intersection A already clear this. Okay, so number of elements of A union B union C will be equal to separately all of the number of elements of A, B, and C in addition minus number of elements of A intersection B plus B intersection C plus n number of elements of A intersection C, and the final one number of elements of A intersection B intersection C. So that is a good important concept. We'll solve it here.